trust me, I really
We're made
do.
for
Recording
a
that. Okay, everybody. So, first thing I want to do. Okay. Yeah, no, the Tesseract is really cool. Someone keeps drawing them up here, and I
It's
can't draw
definitely
them.
the janitor. It's a Goodwill Hunting type of situation.
If James is the one doing it, then damn, good for him.
Who's James? James.
The
The
super.
janitor, you disrespect.
The man.
Goodwill Hunting.
Guy who's
James.
works in this building. Yeah, James.
The guy in the building.
Yeah, he's the building's superintendent. I don't know what's the proper term for him is. He's cool.
The
He's
sanatorium.
really nice.
Yeah, James is my boy.
Anyway, so what I want to do first, everybody, is go over. Okay, class. We'll go over the test to make sure that you understand kind of what you missed. Also, too, this gives you an ample opportunity to fix anything you've missed. Smart. All right. For the first problem, everybody. Okay.
Oh, I did better than you?
For problem number 1 right here.
After doing that.
Okay. The answer is D. Okay. It was pretty straightforward. What you wanted to do is take the antiderivative twice because we're looking for position, or we're giving the acceleration. Okay. A lot of people though didn't do it that way. Instead, they realized, well, wait a minute. A of t at 0 is supposed to be 10. So which one has 10 be the answer when I plug in 0? And the only answer was D. That's a perfectly acceptable way to solve one of these things. Okay. And if you notice that, like on an AP question or something, go ahead and go for it. Use that as a method of solving it, because it makes it a lot faster to do. Okay? So pretty much nobody had a problem with number 1. Okay? Number 2, I did get some interesting answers for. So with number 2, we've got the integral of x squared plus 1 squared dx. A lot of people try to take the integral of the outside, leaving the inside the same, or take the integral of the inside, leaving the outside the same. You can't do either. Okay? This, as it's currently written right now, okay, there's no real easy method to take an integral of this. However, you could expand it, you could multiply it out, then do the integral of it. And multiplying this out gives the integral of x to the 4th, okay, plus 2x squared plus 1. And that one, the antiderivative should be fairly easy, and the answer was E. Okay? Easy antiderivative to do. Okay? All right. Now comes the fun page.
Why isn't x divided by 5?
Huh? Yeah, it is.
Yeah. Plus 2x squared plus 1.
Antiderivative of x to the 4th is x to the 5th plus over 5.
Right, but then it says it's just a plus x and then plus c. Why isn't that x?
Which one are you looking at?
Number 2 crazy?
Number 2 E, yeah.
1 goes to x and then goes to c, man.
Who are you?
You were senile.
No, there's no need for it. Okay? If I expand it out, it's the antiderivative of 1. The antiderivative of 1 is x. Okay? Okay. Moving on. Okay? Go away. Okay. The next page is the one a lot of people had trouble with. Okay? And there were lots of weird kind of little errors and things like that. Let's start with A. This next page. We have the integral from 2 of 2u cubed plus 3 root u cubed, okay, du, right? Now, again, as it's currently written, I can't do anything with it, so I have to rewrite it into an easily done form. This becomes 2u to the negative 3rd plus this here, I can rewrite this as 3u cubed to the 1/2. So I'm going to multiply the 3 and the 1/2 together to get 3u to the 3/2, okay? And now I've got something I can take the antiderivative of easily, okay? This one, most people have no problem with this one. It comes up to be 2u to the negative 2nd over negative 2. Plus, this one here became 3u to the 5/2 over 5/2. And again, because it's an indefinite integral, plus c. A lot of people forgot their plus c's.
You took off for that, right?
I did. Okay. I will totally take off for a plus c. This is not allulus, lass. This is a calculus class. Okay? Remember the plus c. Alright. But that's how that one came out to be. Yeah.
If we forgot the plus C's, can we just, for the,
Yeah, just put them in. Yeah.
write the final answer plus C?
Yeah. Don't forget the plus C. Okay. Question?
About part C, but you.
Well, we're gonna get there. Yeah. Okay. All right. The next question. Number B, part B here. We had the integral of the secant squared of x, or yeah, z. Sorry, z. dz. Not that it matters. Okay, guys, focus. Okay. Again, this is mainly just testing to see whether or not you recognize your trig derivatives. Okay, we're looking at someone's derivative up here. Okay, the secant squared of z is the derivative of a trig function. Which trig function is it the derivative of? The tangent. So the answer is tangent of z plus c. Okay? So part of this is just remembering what your trig derivatives are, because, again, remember, the derivative and the antiderivative, they go together. Okay? The other thing is just, remembering to put the plus c on the end of everything. Okay? All right. Last one. Now, number C here. People, for some reason, did not like this one. 0 to 2 of dy.
Yeah,
Okay?
I've never seen anything like this before.
Oh, no, you've seen it. You just don't remember it.
The
Okay?
derivative of nothing.
One thing you can always do in
From
here
0 to 2.
is remember
Or 1.
there's a 1 in here. Okay?
Gosh darn it.
So this is actually just the antiderivative of 1 with respect to y. So this should come out to be y
It's the one
from
thing
0
I
to
see
2,
right now.
which would be 2 minus 0, which is 2. I think a lot of people also got confused because we were doing things with respect to y instead of x.
Yeah.
Okay? And remember, it just works out the same way. Yeah.
Did anyone get this problem right?
People got it right. Some people did.
I'm not too
Sorry, did you get it right?
Okay.
Yeah, if he didn't get it right, no one gets it right. Sure,
Okay.
Philhouse.
Or some people got it.
Did you get that?
Who has the best grade in this class?
Oh, yeah.
Right now?
They read it.
No, I didn't get
And
it
if
right.
they got it wrong,
Did you get that right?
everyone should get full credit for it.
Shh.
Did anybody get I believe this was an unfair question. And because
Somebody get 100?
no one got it right.
I bet Tilden got it.
No, people got this one right. Some people think it's
Anyone want to? You got it right?
Guessed it though.
Okay. Never mind.
Yeah, you just guessed it.
There were other people who got it right that weren't in
You
this
just
class.
guessed it.
Okay.
We must have not talked about it in this class, David. Just must have like looked it up.
Okay, guys, you can put it if you want, but you still have to. But that's it. Okay. So, remember too.
You should just write in 1 dy so we're not going to.
Well, because you don't write the 1 in these sorts of situations, you just write it as dy. Just get over it, guys. This is the answer. Okay. If I written dx, I guarantee you, more people would have gotten this correct. Okay. I think they were thrown off because it was dy as well. Okay. Because it works the same way. But this is the answer. Okay. All right. Next problem. The one with the integrals, where the one integral is equal to 4, the other integral is equal to -7. So what's the answer? Most people got that the answer is 11. Okay. Comes from that property where you can break up an integral with a random point in between.
Hey, hello. I have a piece
If you have questions on that one, just see me after class.
That'd be awesome.
Number 2. This one. The true or false one. Okay? Watch the language, boys.
This is a brothel.
Number
Go
2
on
here.
YouTube.
Okay? If f and g are continuous functions, which of the following must be true? 1, 2, and 3. 1 is the only one that's true.
Why is 2 not true?
Okay, 2 is not true. I threw that one there on purpose to see how many people would pick 2. Because there's no product rule for integration. Okay? You'll remember, I said that like a million times.
I know.
Okay? The other thing about it too, everybody, is one thing you can always do is come up with just test out some examples if you're ever confused. Now, you can only really do that to show that something's wrong. It's not enough to show that something is true. But if you tested examples, you would have figured out quickly 2 and 3 just don't work. They're not true. Okay? And so you have to kind of go through and take that into consideration while doing these things. Okay? Basically, something can be true part of the time, but in order for it to be true, it has to be true all the time in mathematics. Okay? So I can come up with situations where 2 and 3 are true, but they're not always true. Okay? And so therefore, they don't always work out. Okay? All right. Number 1, work true and false. Almost everyone got this one. 1 is true, 2 is false, the other 2 are true.
Why is 3 not
Okay, why is 3 true?
Yeah.
3 is straight up one of the properties.
I know.
If you flip A and B, it negates it.
A had to be less than B for that to work.
Doesn't matter. Can work the other way around as well. Okay? Could work the other way around. Somebody else had an objection? Which one?
Why is 2?
2 false?
Why is 2?
It only works in certain situations. I come up with situations in which it's true. I'm sorry, in which it doesn't work. For example, let's do.
I thought that was a property.
Nope.
And if it was an A negative A, it's canceled out.
You're thinking from A to A. Okay? So from negative A to A, let's say if I did like x squared here. Okay?
Come on, man.
Okay guys, pay attention. This would become x cubed over 3 from negative A to A, which would be a cubed over 3 minus a cubed over 3, which would be a cubed over 3 plus a cubed over 3, which should be easy enough. That's 2/3, whatever a was. Okay? So that's a situation right there where it ended up being, where I could show why it's false. Okay? It's not equal to 0. Son of a. Now there are situations where it is true, but again, remember, for something to be true, it has to always be true.
Whoa.
Okay? It's to always be true.
Did you see Will Ferrell's George Bush?
I did not.
Oh my
God.
I did no such thing.
We gotta look it up on YouTube.
Next one.
Next one.
This one a lot of people had trouble with, and I think it's just because they weren't used to the wording. If the derivative with respect to x of f of x is equal to the cosine of x, and if f of pi over 2 is equal to 5, what's f of x equal to? Okay? Everybody, people for some reason did not read this correctly. That's saying the derivative of f of x is the cosine of x. So f of x's derivative is cosine of x, and we want what f of x is. So, how do I undo a derivative? I do what? Antiderivative. What's the antiderivative of cosine? Sine. So this would be sine of x plus c. Good. Okay? So f of x is equal to this right here. Now, we want to figure out what the plus c part is. That's what this point here is for. When I put pi over 2 in for x, I get 5 as my answer. So, I'll say the sine of pi over 2 plus c has to be equal to 5. What's the sine of pi over 2? 1. So that means 1 plus c is equal to 5. So c must be 4.
C does equal 4.
So that means f of x, fully written out,
For C, the answer.
sine over x
4.
plus 4. Okay? By the way, everybody, I had some people be like, Mr. Dowell, how can we had to know the unit circle? Well, of course you still need to know the unit circle, even though we haven't seen it. But also, too, there's no excuse for this when it's on the calculator part of the test.
That wasn't in the contract. If it was in small font.
I put it in my thing.
And it's on the calculator portion of the test. So there's really no excuse for it.
Bring a microscope.
Okay? Just did not know what the sine of pi over 2 was.
I already don't like to taste the broccoli.
Alright. Last up. Okay? Last up, the final page, the one where you're doing that definite integral, and we're doing it with calculator and then doing it with real and sums. Hardly anybody had problems with this. Okay, most people got it just fine. Alright. Probably the only mistake I saw people try to make was some people for some reason didn't want to use their calculator to do it, even though the directions say use a calculator. Okay? And so that threw some people off. Okay? So keep that in mind. If it says use the calculator, use the calculator. Especially because the integral I gave you, you actually can't do that one by hand. Okay? You actually can't. I showed earlier that it can't be done by hand to another class. And that's why the book That book exists, by the way, because actually you look that one up in the book to figure out the answer. You have to do it by hand. But we have a calculator which will do the answer for you. In fact, actually, our textbook, everybody, the textbook actually highlights one exactly like this, like 2 chapters from now, saying you can't do these by hand. So it gives you a method to do these, well, without, you know.
Can I turn in my test corrections now?
Yeah, you can turn your test corrections now. Okay.
Oh,
All right, yeah.
For B, I missed it. I was off by multiple. Did you really give it to me?
Yeah. I generally, there is a, which one are you talking about?
For B.
Oh yeah, I just, because you did everything right, you just forgot to multiply it by 3.
Where did I miss the multiply by?
Each partition is, you remember these are rectangles?
Yeah.
So each of these would be that times 3, that times 3, that times 3, because each rectangle has a width of 3.
Okay.
Okay, so that's what you left off, and I didn't feel like, I was just kind of like, yeah, whatever. You want me to take a point off?
No,
Yeah, do it.
All right. Thank you. Yeah, and generally, I figured you just when you're writing out the answer, just forgot to put it in there. That's what I figured. That's why I just said times 3. But okay. Now I know you didn't know there was supposed to be 3. I should have taken points off.
Too late now.
Alright, seriously.
Okay.
George Bush.
So I'll look that up. I'll look that up later.
What was
Look it
that?
up.
As in 2 minutes ago?
It's on HBO.
Yeah. Okay.
Of course you can't even get so.
One thing I want to do today is make sure everybody, we've got down the how both parts of the fundamental theorem of calculus work. Okay, part 1 was the easier part. Basically, we've already seen that numerous times. We don't need to know how it works. Okay, part 2 is the one that's tricky, and I want to go over some examples of part 2. Okay, these are examples basically from homework. So 81 through 92 is the homework. Okay. On page 295. These are the ones we're looking at, okay? All right. So, first thing I want to do is I want to put up kind of the main guts of the matter of the second part of the fundamental theorem, okay? Which basically says that the derivative with respect to x times the integral from a to x of f of t dt is equal to f of x. Focus, everybody. Okay? Guys, you can do corrections later. Focus in on this. Okay? Alright. So, that is the second part of the fundamental theorem. Okay? And so, what we're going to be doing is we're going to be applying this to several problems to see exactly how it's done. Okay? The first one I'm going to do 81 from the homework.
Wait, but how is that tricky?
Well, it's actually not, but a lot of people have trouble reading this or knowing exactly how it's supposed to work.
Any derivative is the function.
Okay. Basically, yes. But people, for some reason, kind of, and this comes from experience, always have trouble doing this. So we want to spend a little time making sure we get this. So let's look at 81. Some of these are indeed easy. Like 81 should not be an issue. We've got big f of x is equal to the integral from -2 to x of t squared minus 2t dt, and we want what big f prime of x is equal to. That's basically saying, take the derivative of this guy right here. Okay? So what does this tell us? We should just get f of x. That is, we should replace the t's in this thing with x's, and that should be our answer. So our answer should just be x squared minus 2x. And that should be it. Okay? Because that's exactly what the theorem is telling us. A is a constant, so this -2 doesn't matter. It's a constant. Okay? X is x. We're told if I take the derivative of the integral from a to x of f of t, I get f of x. That's f of t, so I just change that to f of x, and I'm done. Okay? That should be the answer. Yes?
So if f of x equals the antiderivative prime of x, is that correct?
Yep.
Then how come you don't just take everything away and it's t squared minus 2t? Because it's not, it's still,
Okay.
Isn't that still f of x?
No. F of x here is equal to this integral from -2 to x of all this.
Oh, so you have to,
Okay.
yeah, okay.
So we still have to work it out, and we're told we're doing the derivative with respect to x, of this, and that's how we end up with f of x. Okay? So that's kind of the relationship there. Okay? But still, it's fairly easy to come out with x squared minus 2x. By the way, one thing I can always do here, if I have trouble seeing that this indeed should be the answer, is there's nothing to prevent me from actually working out this regular antiderivative as it's written. Okay? I know what the antiderivative of t squared minus 2t should be, right? This thing should come out to be t cubed over 3 minus 2t squared over 2, so just t squared, and we're evaluating it from negative 2 to x, which means I should get x cubed over 3 minus x squared, okay, minus this thing evaluated at 2, so that should be negative 8 thirds minus 4, okay? Well, we're asked to take the derivative of this thing, okay? So if I take this thing's derivative, okay, this is x cubed over 3 minus x squared. This comes out to be, by the way, negative 20 thirds, so plus 20 thirds. What's this derivative equal to? I would get x squared, because this would be 3x squared over 3. What happens to the 3's? They cancel. Minus 2x, because that's a simple power rule. And then 20 over 3 is a constant, right? So it goes to 0. So look what I'm left with. My derivative is x squared minus 2x, which is exactly what the theorem told me my derivative would be. So when in doubt, you can always just apply the regular old power rule to it. Or sorry, regular old antiderivative rules to it, and get our answer. Okay? It's just the theorem helps us do this much more quickly, doesn't it?
This is the fundamental theorem of calculus.
Yeah, this is part 2, fundamental theorem. We're working with it, okay? Part 1 we covered a lot on Saturday, so you might want to watch the video of it.
Oh, Saturday, that's what I'm missing.
What?
That's what happened.
Alright?
That test. That was-
What is that you drew on this?
I didn't draw that. Someone did. That's a hypercube.
Not that
It
hard.
was the
Or a
janitor.
tesseract.
How do you do
I don't know who
I
drew
don't know, just look at it, man.
it? It was the janitor.
Alright. But this is how this one works. Let me show you another example, okay? This one's 82. Okay? From the book.
You're the janitor.
Zip it. Okay. 82 here, f of x equals the integral from 0, or from 1 to x, of t squared over,
Is that big F?
yeah, big F of x, okay. And we want its derivative. So again, we're just applying the second fundamental theorem of calculus. In this case here, if I tried to actually do the antiderivative of this guy, I'd run into a problem real fast, wouldn't I?
Yeah.
Does that thing have an easy antiderivative to do? No. In fact,
What?
that one is like next to impossible to do the antiderivative of by hand. Okay? Earlier I wanted to demonstrate it, so I looked it up in the book right there. That's behind the camera. And, you know, to show you what it is. And it's not nice. It's really messed up. Okay? But we can still figure out the answer because of the theorem. The theorem just says, okay, we're going from a constant to x, so this thing should just be equal to f of x, and f of x in this case would be x squared over x squared plus 1, and that would be it. So the theorem took something that was impossible for us to do, and made it so we could figure out the answer. And it's that easy.
But that only works. What if it's the opposite? What if it's x? What if it's
X to 1?
going to 1?
Oh, it would be negative this.
Oh, okay.
Because remember,
Yeah,
we have that
A and
property.
Negative A, right?
Yeah, you just flip them.
Yep.
You flip A and B, it's negative. Okay? Now, here's where things get a little trickier. We're going to look at two that are a bit harder. Okay? The first one we're going to look at is 87 here.
Yeah,
And this one right here is big F of x is equal to the integral from x
Do the homework.
to x plus 2 of 4t plus 1 dt. What's the problem with this one right here?
Oh, it's not a constant.
X is not a constant at the bottom, right?
What?
And the fundamental theorem says it's from constant to x. That's from x to another x plus 2 in this case. So that makes this one a lot, so really I can't use the theorem on this one to figure out what f prime of x is. Okay, right? But what can I do?
Negative f prime of x, right?
Well, isn't that just something I can easily do the antiderivative of?
Yeah.
So why don't I just do the antiderivative of it and plug in x and x plus 2?
Why not?
Exactly. Why wouldn't I do it that way? That's exactly what you would do, okay? And so this thing would become 2t squared plus t
Plus,
from x, no plus c.
what?
It's definite. We're going from x to x plus 2.
Indefinite anymore.
Indefinites has the plus c, definites don't, okay?
What's the straight problem on the test?
The straight line tells you I'm evaluating it at x plus 2 and subtracting it the evaluation from x. That's what that means. It's the notation for it. Okay? So this thing then comes out to be 2 times x squared plus 2, sorry, x plus 2 squared, excuse me, plus x plus 2 minus 2x squared plus x. We can work this out real fast. That's going to be x squared plus 4x plus 2, or 4, exactly. So it comes, multiply that by 2, so it's 2x squared plus 8x, okay, plus 8 plus x plus 2 minus 2x squared minus x. Stuff cancels.
2x.
Add that together, get 8x plus 2. So big F of x is equal to 8x plus 2. We want the derivative of it, which is just 8. Derivative of 8x plus 2 is 8. Or 8x, actually it's 8x plus 10. I keep making a mistake here, because it doesn't matter. We don't care. Okay? And that is that. Okay? Oh, nothing else crazy to it. So, on the surface it looks impossibly difficult to do, but in reality it makes it rather easy to get the answer. By the way, if you look in the back of the book, 8's the answer. It just comes out to be 8.
Impossible.
Okay?
I did.
8x plus 10 is what big F of x is equal to, and we want the derivative of big F of x. So it's a big, yeah. Yeah. Okay?
Look, I did it.
Alright,
Guess whose is better?
next one. Okay? Let's look at 90, because 90 is the first one where we get something weird going on with this. That we're going to use the theorem, but things get a little bit stranger. Okay? So with 90, we've got big F of x is equal to the integral from 2 to x squared of 1 over t cubed dt. And we want f prime of x. Now, here's why things are stranger here. Okay? I'm used to doing this from a to x, right? So, from a constant to x. So, from like 2 to x. But do I have just x? No, I have x squared this time around.
There we go.
Now it's going to affect things slightly. Okay? It's going to change the outcome a little bit. Okay? We want that to be a single thing. We don't want that to be x squared. We want that to be x. Or some other variable that I can deal with. Okay? So what I'm going to do is do what's called a substitution. I'm going to set x squared to be equal to some random variable and substitute that in. Okay? So I'm going to come up here and say x squared. We'll call that equal to u. Okay? And then 2x would be equal to the derivative of u. And we do need what du is. Okay? As you'll see as we work this out. Okay? That means I can rewrite this as big F of x is equal to the integral of from 2 to u of 1 over t cubed dt. So the derivative of this thing should be 1 over u cubed du. Okay? Now, when I put x back in though, I'm going to have 1 over x squared cubed times the derivative of u, which is 2x. So my final answer should be actually 2 over x to the 5th. Okay? Now, note here we did something strange. We put a du here. okay, that we didn't see before. Part of that is because we're no longer doing things with respect to just x, we're doing it to x squared. And that's going to change things out a little bit. We got to account for that. And we account for that by saying we know there should be a derivative in there, okay? Basically, we're reproducing a chain rule,
It's tough stuff here.
okay?
Wait, where'd you get the 4?
What for?
What's on the bottom?
You.
Oh, that's a U.
That's a u,
Sorry.
Hold on.
okay?
We have a quiz on this tomorrow or Wednesday?
Actually, I removed it. There's not really a quiz.
right?
Yes!
Okay. I changed it, so really the only thing left at the end of the week is the AP problem.
I've checked out.
Okay. So you guys still do the AP problem, man.
AP problems.
Still gotta do the AP problem, okay? Alright, so that changes things up. Now, someone, guys, focus. Someone might say, okay, that seems way too weird. Why do we do it that way? Again, let's go back to the original up here and actually do out what it says. Because there's no reason why we can't take the antiderivative of this, right?
Right.
So let's do that, okay? Let's redo this without doing a u substitution. F of x is equal to the integral from 2 to x squared, 1 over t cubed dt, which would be t, remember, this comes up as t to the negative third, so it's t to the negative fourth over negative 4 from 2 to x squared. Sorry, I'm being an idiot. It's t to the negative second over 2, negative 2, from 2 to x squared. Okay? We work this thing out here. Okay? We're going to get this thing to be, I'm going to rewrite this as negative 1 over 2 t squared from 2 to x squared like so. That gives me negative 1 over 2x to the 4th, okay, minus negative 1 over 8. That's what this comes out to be, okay? So, big F of x is equal to negative 1 over 2x to the 4th minus negative 1/8, okay? Or, we're going to do the derivative of that.
This proves to be one of the more difficult things.
This right here is a derivative. I'm going to rewrite this as minus 1/2.
Can you do that as x to the negative 4th to bring everything up top, or
Yeah.
should you not?
That's what I'm going to do right now.
Okay.
Okay. So we're going to take the derivative of this right here. So that's going to be negative, basically
Negative 3, right?
negative 1/2 times negative 4 x to the negative 5th. Now why negative 5th?
I thought you were adding 1.
We're doing a derivative, which means we subtract 1.
Is that,
Okay?
You're an idiot.
And then the 1/8 goes to 0. What does this clean up to be? The negatives cancel, the 4 and the 2 cancel, giving me just 2 x to the negative 5th, which comes out to be 2 x to the 5th. So notice, I got the same answer. Okay? I did it differently, but I got the same answer. So the substitution up top was a quicker way to do on the bottom what I needed to do. Okay? And that's something you could do with these integrals. You can do these substitutions. In fact, what I did up here is a common method of solving integrals that we're going to learn on, I guess, Wednesday. This is called a U substitution. And you use it, okay, whenever you have a situation where you have an integral you can't quite do, but if I can identify something to be U and the derivative of something in the problem, I can substitute them and get my answer out. Okay? And we'll look more on that on Wednesday, okay? Alright, everybody.
Can you scroll down real quick?
Yeah.
Sorry, you remember?
Ding! Checked out.
Alright.
No, you remember when Jack?
Oh.